Hello everyone, my name is Ronaldo Hegruzam, currently studying as a first year student in Sri Venkateswara College of Engineering, Bengaluru. In today's topic, we are gonna learn about lasers and its various applications. Before coming to the video, here is a brief outlook of the contents. The first part is the introduction to lasers, and coming after that is the various interaction of light with matters. And in the next part, we are gonna learn about these different types of interactions. And after that, we are gonna learn about the conditions for laser actions and lastly, the various applications of lasers. So first of all, what is a laser? Well, it is an acronym for light amplification by stimulated emission of radiation. They are devices that can amplify light. They possess unique properties like coherence, which is a property of laser, in which emitted radiation after getting triggered is in phase with the incident radiation. Unidirectionality. Laser beams travel in only one direction. Monochromaticity. Compared to any other radiation, the laser beam is highly monochromatic. Focusability. It is a property of laser in which it can be focused to an extremely fine spot. Before going in depth with lasers, we are first gonna learn about the interaction of an electromagnetic wave with matter. This interaction with matters leads to transition of atom from one energy state to another. First is absorption. If the transition is from lower state to higher state, it absorbs the incident energy. Second is emission. And if the transition is from higher state to lower state, it emits a part of its energy. There are three types of these interactions. First one is induced absorption, in which the incident photon is absorbed by the system and as a result, the system is elevated from lower energy state to a higher state, wherein the difference in the energy of the two states is the energy of the photon. Second one is spontaneous emission. In this type of emission, photon is emitted by the transition of a system from higher energy state to a lower energy state without the aid of any external energy. Third one is stimulated emission. In this type of emission, photon is emitted by a system under the influence of a passing photon of just right energy, due to which system changes from high energy state to lower energy state. The photon thus emitted is called stimulated photon and will have the same phase energy, direction of movement as that of the passing photon, called the stimulated photon. The incident photon stimulates the excited atom to emit a photon of exactly the same energy as that of the incident photon. The two emitted photons have same phase, frequency, direction, and polarization, with the incident photon and results in coherent beam of radiation. This kind of action is responsible for lasing action. So now that we know that stimulated emission is the one that causes laser action, let us now talk about the various conditions for laser actions. First condition is metastable state. It is special type of excited state wherein the lifetime of atom is more than normal excited state. This state plays an important role in lasing action. In metastable state, atom stays of order of 10 to the power minus 3 to 10 to the power minus 2 second. In normal excited state other than a metastable, atom stays of order of 10 to the power minus 8 to 10 to the power minus 9 seconds. Second condition is population inversion. It is the state of system at which population of a higher energy level is greater than that of lower energy level. To understand about this inversion, let us consider three energy levels of the system, where of the system E3, E2, and E1, where E3 is greater than E2 and E2 is greater than E1. E2 is the and E2 is the metastable state of the system. Atom gets excited from state E1 to E3 by means of external source and stay there for short time. These atoms undergo spontaneous transition to E2 and E1. The atoms at state E2 stays for longer time. A state is reached in which the number of atoms at state E2 is more than the number of atoms at E1, which is known as population inversion. Let us now talk about the various applications of laser. Lasers are widely used in medical application. For example, in eye surgery, it is used to correct vision in people who are nearsighted or farsighted. Lasers are also used in skin treatment. In skin treatment, it is mainly used for cosmetic like to remove wrinkles, moles, warts, etc. Lasers are also used in defense by using a highly power pulse laser which is directed towards the enemy target from the transmitter. The beam bounces back from the surface of the target as a reflection. The rangefinder's high-speed track measures the exact time of incident and reflection of the pulse and then convert it to distance. Lasers are also used in barcode scanners. Before coming to how laser is used to scan a barcode, let us first learn about barcode. A barcode is a printed series of parallel bars or lines of varying width that is used for entering data into a computer system. Now that we have learned what is a barcode, let's see how laser is used to capture information contained in barcodes. Laser uses laser light source along with oscillating mirrors or rotating prisms to scan the laser beam and back across the barcode. Photodiode measures the reflected light from the barcode by generating an analog signal which will be converted to digital signal letters. Lasers are also used in printers. Laser printers were invented at Xerox in 1969 by Gary Starkweather. It is a printer linked to a computer producing good quality printed materials by using a semiconductor laser to form a pattern of electrostatically charged dots on a photoconductor drum, which attracts toners or dry ink powder. The toner is transferred to a piece of paper and fixed by a heating process. I hope that you guys have learned something about lasers through this video, and thank you so much for watching.